edit the weights that store the fact, or just hide the output. An LLM asked to forget a piece of memorized personal data can do one of two things: erase the knowledge from the weights, or merely suppress the answer until a resurfacing attack drags it back out. Existing unlearning benchmarks grade only the output, so they cannot tell the two apart. LACUNA is the first testbed with ground truth parameter-level localization. Synthetic personal data is injected into known weight subsets via masked continual pre-training, so one can measure directly whether an unlearning method edits the weights that actually store the target fact. A team at Mila and McGill shows every state-of-the-art method edits indiscriminately, localization, AUC, at chance, while an oracle that knows where to edit hits 0.91. The forward pass. Inject 1,200 synthetic profiles into 6 non-overlapping parameter groups, 5% of weights each, feed forward and attention only, never norms or embeddings. Each group gets a binary mask, bit-packed, 1 bit per parameter. That gives ground truth. The fact lives in these weights and no others. Now unlearn. Alpha edit traces causally and edits FFN key value memories. Memflex localizes by gradient divergence. SimNPO runs negative preference optimization, the soda gradient method. Oracle Grad receives the ground truth forget mask and restricts edits to it, with a trivial gradient difference objective, ascent on forget, descent on retain. Score each weight by how much it changed, then compute ROC, AUC in mask weights versus out of mask. 1 means perfect localization, 0.5 means indiscriminate, the gap it fills. Unlearning benchmarks grade only output behavior. Does the model stop emitting the forgotten fact, and does it keep its general capability? But a model can obfuscate knowledge without erasing it, and resurfacing attacks, fine-tuning on a little held-out data, recover what was supposedly forgotten. The localize, first unlearn second paradigm, ROM, Memit, Alpha Edit, Memflex claims to find the right weights before editing. But the community had no ground truth for where a fact lives, so no benchmark could say whether the localization step actually worked. Attribution methods would be circular. LACUNA breaks the circle by planting the fact in known weights. The hinge in one chart. Table 2, OLMO21B, email, localization precision, AUC, Alpha Edit, 0.500. Memflex 0.500, SimNPO 0.515, all 3 at chance, indiscriminate editing. Oracle Grad 0.915. The pattern holds across all 4 fields: email, phone, birth city, driver license, and both model sizes 1B and 7B. SOTA ranges 0.500 to 0.522. Oracle Grad ranges 0.910 to 0.915. No state-of-the-art method targets the weights that store the knowledge it claims to erase. Precision tracks robustness. After unlearning, fine-tune the model on a little held-out personal data, then count how many of 100 forget profiles leak across 200 prompts. Success at 200, lower is better. Alpha Edit leaks 87% at 1B, Memflex 23. SimNPO 13. Oracle Grad 8, the most resistant. The imprecise methods leak heavily, the precise oracle leaks least. This is evidence the knowledge was genuinely erased, not just suppressed. Precision correlates with resilience. The lever, in pictures. Before, the knowledge is hidden, the output is suppressed, the surface looks clean, but the fact still sits in the weights, waiting for a resurfacing attack. After, the knowledge is erased, the weights that stored it are edited, the fact is gone. Obfuscation suppresses the answer, erasure removes the substrate, the same output, 2 different weights. LACUNA's metric tells you which happened. Where the headline overstates, Oracle Grad's resurfacing edge is not universal. On email and birth city, the textual fields, Oracle Grad leaks least, and the imprecise methods leak heavily. But on the numerical fields, phone and driver license, SimNPO, and Oracle Grad are equally resistant to the straightforward attack. The edge holds on 2 of 4 fields. And Oracle Grad is an oracle, handed the ground truth mask, so 0.91 is an upper bound on what a deployable localization method could achieve, not a method you can run. 5 honest caveats. First, Oracle Grad is an oracle, given the true mask, so it upper bounds what localization-based methods could achieve, it is not deployable. Second, the personal data is synthetic. From Panorama, real-world memorized data may distribute differently. Third, the resurfacing attack is a single straightforward fine-tuning run, and the author's flag 7B resistance may reflect attack weakness, not model strength. Fourth, localization precision is necessary but not sufficient. A method could be precise about the wrong subbehavior. Fifth, birth city extraction strength stays high only because city names are low entropy, read exact match and probability, not extraction strength, for birth city. And SimNPO's erasure comes at utility cost, 7 BMM, LU drops 28.8 points. Edit the weights that store the fact. LACUNA reframes LLM unlearning from, did the output change, to, did the weights change in the right place? Every state-of-the-art method edits indiscriminately. AUC a chance, only the mask oracle reaches 0.91. Unlearning progress now requires better localization, not better edit objectives. Subscribe for the next breakdown.